Hello, and today's purpose of the day is I can add, subtract, and multiply radical expressions, otherwise known as completing operations with radical expressions. So the first examples we're going to look at are adding and subtracting expressions with like radicands. You can think of a like radican as like terms, only this time we're looking at what's underneath the radical must be the same with another radical and what's underneath that. So for example, if you can recall, a like term would be 2x and 3x because those both share an x. Here we want to see like square root of 3 plus the square root of 3, and then we'd add those up, and that's like 1 square root of 3 plus 1 square root of 3, which would give us 2 square roots of 3. So that's a little bit about what a like radicand is. So if we look at number 1 here, we need to simplify this expression. So what I see is I see 2 like radicands, well actually, excuse me, 3. I see 6 square roots of 5 plus 2 square roots of 5 minus 5 square roots of 5. And I'm just going to add those like I would add or subtract like terms. So 6 square roots of 5, 6 plus 2 is 8. 8 minus 5 is 3, and I don't want that marker, is 3 square roots of 5. And that would be my final answer. Let's look at number 2. Number 2 is a little bit different in that I don't have all the same terms being like radicands. I see 7 square roots of 2 matches up with a negative 6 square roots of 2. And I see, change colors here, I see 8 square roots of 11 and negative 4 square roots of 11 that are together. So here's what I'm going to do to add these like radicands or simplify this expression. I'm going to take the 7 square roots of 2 and subtract 6 square roots of 2 and get 1 square root of 2. And I'm going to take 8 square roots of 11 and subtract 4 square roots of 11 and get 4 square roots of 11. So all as I do is I add the numbers that are in front of the radical if I have like radicands. Add or subtract the numbers that are in front. Now we are going to look at adding and subtracting expressions with unlike radicands. So we are going to not see the same numbers under the radical here. But we should be thinking that if we can simplify these terms or these radicals, that they might perhaps turn into radicals that are like each other, so turn into like radicands. Not all the time, but many times they will. So let's look at 6 square roots of 45. I'm going to break down 45 into the square root of 5 and the square root of 49, and take out the square root of 49, which is 7. And I already have a 6 in front of the radical, so I'm going to multiply 7 times 6 to give me 42 square roots of 5. Now I'm going to break down 125, and that breaks down into 25 and 5, and the square root of 25 is 5. But I already have a 3 outside the radical, so 5 times 3 is 15 square roots of 5. So, ooh, I'm seeing some like radicands here already. And let's look at now the last term to simplify, breaking down 80 into 16 and 5, and the square root of 16 is 4. And I have nothing in front of the radical, so I just can take out the 4 and get plus 4 square roots of 5. So what do you know? All of these terms are like radicands because they all have square root 5 under the radical. So I'm now just going to add these terms. I'm going to add 42 plus 15 plus 4 to give me 61 square roots of 5 for my answer. All right, let's look at number 2. Number 2 says simplify. Again, some terms that don't appear to be like radicands, but we can be thinking perhaps they might turn into like radicands. And let's look at 6 square roots of 27. I'm going to break down 27 into the square root of 9 and the square root of 3, and out comes a 3. And I already have a 6 in front, so 6 times 3 is 18 square roots of 3. Move on to my second term and break down 12 into 4 and 3. Square root of 4 is 2, but I have an 8 in front, so I'm going to multiply 2 by 8 to give me 16 square roots of 3. And then last but not least, the last term here, I'm going to break down 75 into 25 and 3. Square root of 25 is 5. I already have a 2 in front, so I'll write down plus 10 square roots of 3. And what do you know? Again, we have like radicands, so simplifying numbers that we didn't have as like radicands to begin with, simplified to become the same. So let's add up 18 plus 16 plus 10 and get 44 square roots of 3 for our answer. Now we are going to multiply radical expressions, so let's look at example 1. Number 1 says simplify 2 square roots of 3 times 4 square roots of 6. When I look at this problem, I want to look at what's outside the radical. Notice I have a 2 and a 4, and what's underneath the radical, a 3 and a 6. And I'm allowed to multiply what's outside the radical together, and I'm allowed to multiply what's under the radicals together. So let's start with what's outside in purple. 2 and 4, so 2 times 4 gives me 8. And then what's underneath the radical is 6 and 3, so I'll multiply 6 by 3 and get 18. But that's not my final answer because I can continue to break down 18 because I know there's a perfect square in there of 9 and 2, and the square root of 9 is 3. But I already have an 8 out in front, so 8 times 3 gives me 24 square roots of 2 for my final answer. And again, I could check this by typing into my calculator the original problem here of 2 square roots of 3 times 4 square roots of 6, and type in to my calculator 24 square roots of 2, and I should get the same answer in my calculator, same calculation, which you will. So this is our final answer. Let's look at number 2. I have a little bit more going on here in number 2. I see 4 square roots of 2 times 3 square roots of 2 plus 2 square roots of 6. And now you see a number followed with parentheses and terms inside that parenthesis, so that should remind you to use the distributive property. And let's look at the first set here. 4 square roots of 2 times 3 square roots of 2. Again, I'm allowed to multiply what's outside the radical together, and what's underneath the radical gets multiplied together. So 4 times 3 of what's outside the radical is 12. Square roots of 2 times 2 is 4. I'll worry about breaking that down in just a moment. Let's now look at what else we have in this problem. 4 square roots of 2 times 2 square roots of 6, and that gives me 8 square roots of 12. And that again is because I can multiply what's outside the radicals together and what's underneath the radicals together. And now let's simplify because we can do some simplifying here. Square root of 4 is 2, so out comes a 2. There's nothing left underneath. So 12 times 2 is 24. Plus, let's break down 12 into square root of 4, square root of 3. Out comes a 2. But I already have an 8 out in front. So that turns into 16 square roots of 3. And now I look and see if I have any like radicands, but I do not have any like radicands or anything that I can simplify anymore. So that is my final answer. Okay, so now let's look at a word problem under the multiplying radical expressions. So find an area of a rectangle in simplest form with a width of 4 square roots of 6 minus 2 square roots of 10 and a length of 5 square roots of 3 and 7 square roots of 5. So I'm going to draw a picture here of my rectangle, and my width is 4 square roots of 6 minus 2 square roots of 10, and my length is 5 square roots of 3 plus 7 square roots of 5. All right, so I need to find the area. So I'm going to multiply the length and the width together, the two products here. So 4 square roots of 6 minus 2 square roots of 10 times 5 square roots of 3 plus 7 square roots of 5. And I'm going to FOIL. Could use the box method as well, but I'm going to FOIL here. So I'm going to multiply 4 square roots of 6 by 5 square roots of 3 and get 20 square roots of 18. Worry about simplifying at the end. Now 4 square roots of 6 times 7 square roots of 5 to give me 28 square roots of 30. Now negative 2 square roots of 10 times 5 square roots of 3 gives me negative 10 square roots of 30. And last but not least, negative 2 square roots of 10 times 7 square roots of 5, which is minus 14 square roots of 50. Move that over there. Now I'm going to break down the radicals and see if there's any like radicands that I'll see. So move this up a little bit. Break down 18 into 9 and 2. Out comes a 3, but I already have a 20 out in front. So that turns into 60 square roots of 2. 28 square roots of 30, there is no perfect square that goes into 30, so it actually cannot be broken down anymore. So I'm just going to write that as 28 square roots of 30. And that goes for the same as, minus 10 square roots of 30. But hey, I have like radicans with those 30s right there, so that's something good to look at. And then 50 can break down into 25 and 2. Square root of 25 is 5, but I already have a 14 out in front, and 14 times 5 is 70. So this is minus 70 square roots of 2. So aha, that's good because I see some like radicans here. I have 6 square roots of 2 minus 70 square roots of 2. And I also have 28 square roots of 30 minus 10 square roots of 30. So let's look. 60 square roots of 2 minus 70 square roots of 2 is negative 10 square roots of 2. And then 28 square roots of 30 minus 10 square roots of 30 is positive 18 square roots of 30. And now I look at my answer and see if I can simplify any more, and I cannot. I don't have any more like radicans, so I'll just make sure I label and say units squared, and that is my final answer. Thank you for watching today, and please check Google Classroom for your homework assignment to get started. Have a great day.